Theory. When we are dealing with HVAC, we have a lot of areas of the ductwork that we have to pay attention to, either whether it's installing it or servicing it. So in sheet metal, we are going to have two types of plenums that are going to be, first off, connected directly to the air handler or furnace that we're dealing with. Okay, that's going to be our return and our supply. From there, we are now going to connect our trunk lines or our branch lines that are going to be used to distribute the supply air to each area of the home. Once that is all completed, then you are now going to be inserting and putting in all of your return air grills, all of your supply registers. If it's going to have air conditioning, obviously the evaporator coil is going to have to be also installed in the supply duct so that you can have air conditioning. Okay, so with ductwork, the first thing that has to happen is the ductwork has to be sized properly. We got to be able to move the correct amount of air through the ductwork to deliver it to all of the spaces. If we are not able to do that, then you are going to run into a lot of air issues, customers complaining that the home may not be cooling efficiently, or maybe a room doesn't seem to be getting down to temperature, but the rest of the house is, so on and so forth. So you have, in this picture here, we have a plenum, or what we call a spider system. Okay, this is basically what we're just talking about. You have your return duct coming down through here. Here's your supply plenum with your trunk line and all of your branches coming out to feed each area of the home. Here you have what we call an extended plenum. You may have seen this stuff on commercial buildings, maybe because the air handler is up on or the rooftop is up on the roof. It extends down. Some cases that's not necessarily a heating and air conditioning system. That can actually be an exhaust system, depending on what we're dealing with here. In case you could see, this isn't actually an Oriental grocery store, so this is probably something along the lines of a exhaust system. Here you have your reducing extended plenum. As you can see, the ductwork, as it goes down the basement, it starts to reduce in size. The reason why we do that is because we want to be able to make sure that the static pressure inside the ductwork remains constant, so that we are able to push the air from the air handler all the way down to the very, very end of the ductwork. Okay, you can also see in this picture that there has been some modifications to the ductwork. Now, as a mechanic, you would actually want to be in here and you would want to see what type of modifications have been done, and if so, is it affecting the air quality and the velocity of the air. Now, from experience, I can personally tell that this air volume here is going to be substantially greater, because we're going from a substantially larger piece of ductwork and we're reducing it down to a much, much smaller piece of ductwork. So the velocity down here is probably going to be much greater. So this person here is probably experiencing air noise, almost sounding like a freight train coming out of the supply duct. Here you have what we call a perimeter loop. These are commonly found in a lot of your condo complexes, apartment buildings, maybe homes that are on a concrete slab, where the air handler is strategically placed right there in the center of a home, and the ductwork, the supply duct, is actually ran underground, where the return will actually be mounted up on the top. So as far as sheet metal is concerned, with the material that we're going to use, there's a lot of different ones out there. We have galvanized steel, which is really used in a lot of your commercial, industrial type applications. Galvanized spiral duct, same concept. Aluminum duct, that's going to be found in a lot of your residential In some residential applications, fiberglass or fiberboard. Yep, that's definitely going to be in a lot of your residential older style units. And then you'll have your vinyl or foil-backed flexible duct. So with ductwork, as far as the fittings are concerned, there's a lot of different fittings out there that's going to be used to make your trunk lines and your supply runs. You're going to have your takeoffs, you're going to have your supply boots, you're going to have elbows so that we can make the air turn in different directions, T's if we're going to go in 2 different directions, Y's, transition fittings, which we're taking ductwork from one size down to another, reducing collars. I like that. It says reducing dollars. Sorry, but it's supposed to be reducing collars. Your end caps, and obviously dampers. You're going to have dampers in your supply runs because you need to be able to regulate and adjust for the airflow for each part of the room. Your diffusers are used to break up the air and mix the air with the room air. So diffusers, you have different styles. You have your ceiling mount, which is obviously mounted in the ceiling, common in a lot of your commercial, industrial, banking centers, stuff like that. Your wall mount, which is, like it just says, it's mounted in the wall. Then you'll have your baseboard mount or your floor mount. So the return grill, this is an important part of your HVAC system. If we're supplying air, we got to be able to have that air that's getting blown out get returned back to your HVAC system. So the purpose of the return air grill is to allow room air to be pulled from the room into the return air duct where it can now be conditioned and then recirculated to the space. What we mean by conditioned, if it's in heat, obviously we're going to take that air, we're going to pass it over the heat exchanger, heat it up, and then push it back out the supply. If it's air conditioning, it's going to go through the evaporator coil where we can condition it, remove the humidity, cool it off, and then bring it back out into the supply air. So what's the difference between a grill, a register, and a return? Well, your heat registers are vents, covers that cover the hole in the wall or floor where the duct enters the room. Okay, louvers or dampers are often attached to the back of these, so we have some way of adjusting the amount of heat that's coming into the space. Okay, these adjustables are there, and they can be opened or closed to the register to allow and adjust for airflow. Okay, the grill is a vent cover through which air is blown into and out of a room for circulation back to your central heating and cooling unit. A grill has no air damper on it whatsoever because we need to have the air to flow freely through that grill because we do not want to have any sort of obstructions. Okay, an air return is a vent grill that is usually located either in a hallway or in a ceiling, and its purpose is to extract air from a room and recycle it through the system to further condition it by either cooling it or heating it. Your air returns do not have any sort of damper in there. Okay, returns are completely open. They have to allow the air to move freely. Okay, your air filter grill or return air filter grill, or sometimes what is called a return filter frame, is what's going to contain a vent cover that attaches to a filter frame assembly, as you can see in this picture. You see these a lot in a lot of homes where these are in the wall with the little latches. These latches pull out and the filter will be attached right in here where you can actually change it. So when we're connecting our ductwork together, we're going to be using basically these 3 types of connecting devices. We have our drive cleats, we have our S-locks, and if it's major commercial industrial type ductwork, you're going to be using the metal fingers, which is basically a gasket, nuts and bolts, and those metal fingers that are going to hold the ductwork together, because remember, in commercial industrial we are using a lot more velocity and a lot more static pressure to move air from point A to point B. When it comes to supporting ductwork, it is very good practice to support the ductwork every 4 feet of run using metal hanger straps. Okay, according to the International Mechanical Code Book, this is what they are expecting. Every 4 feet of any ductwork that's going to be suspended in the air, you have to suspend it and support it every 4 feet. Okay, your square and rectangular and round duct should be supported, including all of your branch lines. Okay, with system operation, remember, air, we have to move the air. That's part of our job. So we need to make sure that ductwork is installed properly and sized properly. And to do so, we have to make sure that the pressures and the velocity of the air is correct. Okay, we do not want to have too low of duct pressure. We don't want to have too high of duct pressure. That's going to cause issues. Okay, systems will run less efficiently if if that's what's happening. Okay, we want to try to avoid really long runs. Okay, and if we have to make sure that the duct pressure is higher so that we are able to move the air down that run. What we can run into some cases, if that is the case, we can run into the system being noisy. Okay, sounds like a freight train's coming out of the air vents. Okay, when a system that is properly designed, really you shouldn't be hearing. Okay, if it turns on, you really shouldn't be hearing too much of any sort of air movement coming out. If you do, there could be a possibility of an issue. It would have to be investigated. Okay, to check your velocity and stuff like that, you're going to need to use what is called a velometer. Okay, a velometer is what measures the air, and it measures it in feet per minute. Okay, common acceptable duct velocities can be found as I put down here in this table below. These are basically what your rule of thumbs for your readings on different areas can actually be. Okay, air intake from your outside, if it's a public area, you're looking at anywhere between 500 to 900 feet per minute. Industrial areas, you're looking at maybe 1,000 to 1,200 feet per minute. Okay, residential ductwork, in a lot of cases, your main duct could be anywhere between 700 and 900. Again, that changes. You have to do the calculations to figure out what needs to be moved. Your branch ducts could be anywhere between 500 and 600 feet per minute. Okay, supply registers and grills, 250 to 400 feet per minute. So again, this is all comes from International Mechanical Code, but again, these numbers do change depending on your application, obviously the size of the unit, how much air we need to move, so on and so forth. Okay, velocity is lost when we are due to friction. Anytime we are making the air turn using elbows, dampers, stuff like that, that's all friction. And anytime the air passes over these areas, the velocity will slow down. Okay, so we want to try to always keep your ductwork as straight as possible. Granted, sometimes that's almost impossible to do, but the real rule of the game is to try to keep any sort of return air and supply air ducts as straight as possible to try to avoid your friction loss. And by doing so, you're actually able to keep your blower speeds down, and you might be actually able to size the ductwork down just slightly to try to compensate for stuff. Okay, balancing a system ensures that you have proper airflow to all the rooms. This should be done after a system is installed. Someone comes in and they just take a measurement of each area of the room to make sure that the exact amount of air is going into that room. And if it isn't, the dampers are now adjusted to compensate and move air from one area to another so that you can get a better balance. A balanced system ensures that that system is running at its most high efficiency and most likely will have very little issues. Okay. One other thing is that we need to discuss is duct cleaning. If you have dirty ducts, you can have a lot of issues, okay, especially people who have like really bad allergies, stuff like that. With those ducts being dirty, it only enhances those problems. So you have allergies, you can have illness, you can have humidification problems. We have the word mold can actually grow in ductwork, especially if it's insulated on the inside. Eye irritation, sinus congestion, headaches, you name it, scratchy throat. So sometimes it's actually good to inspect the inside of the ductwork, if at all possible, to see whether or not it's actually dirty. If it is, you can always make the recommendation to the customer to have the ductwork actually cleaned if your company offers it. Hey, then it's just another job for you guys to have, and hey, it's more money for you. Okay, with duct cleaning, it starts with proper installation precautions. We got to have proper design, and we got to have proper access. Okay, you can look at these two pictures here in this slide. Which one is better? Which one is more easier to be accessed? The one with all the ductwork wrapped around the air handler, or the one where you can actually easily access the air handler and actually maybe look inside some of the ductwork? Okay, the one on the right is the one that you really want to see. Okay, you're able to access the air handler, take the panels off. You're accessing the blower. You can clean it. You're actually even able to take off some of the ductwork so that you can peek your head in there to see whether or not the actual ductwork is dirty on the inside. The one on the left, you can see that that one has been masticed and taped, and just absolutely, it looks like a spider web of misery. Yeah, this is the type of stuff that you really want to try to avoid. As a mechanic, you may want to also maybe recommend to that homeowner to possibly have that ductwork redone so that you have better velocity and less chance of having the duct being dirty.